Session 1.2 Angle Relationships and Similar Triangles. Vertical angles. Vertical angles have equal measures. Look at this example. The pair of angles N and P. This angle and angle RMQ, they are vertical angles. When they are vertical angles, that means these two angles are equal to each other. If this is a 45 degrees, then this guy is also 45 degrees. Okay, how about this one? Angle QMN and the angle RMP, these two angles are vertical angles. So they do have an equal measure. Okay, vertical angles. Parallel lines. Parallel lines are lines that lie in the same plane and do not intersect. If I have two lines, if they are parallel to each other, no matter how long I extend it, they never intersect to each other. And we call these two lines are parallel. When we have the two lines are parallels, M and N, and also when a line Q intersect two parallel lines, and the Q is called a transversal. Okay, transversal here. Okay, parallel line, we could write it down M is parallel to N. This is the notation for parallel. And then we say angle 1 and angle 4, these two are vertical angles. That means angle 1 will be equal to angle 4. Same idea for angle 2 and angle 3. These two are vertical angles. So angle 2 will be equal to angle 3. Same idea, that will be angle 5 and angle 8. These two are vertical angles. So angle 5 will be equal to angle 8. And then last one, angle 6 equal to angle 7 as well. One more time, the reason they are equal to each other because vertical angles. Okay, angles and relationship. The first one, we're gonna call alternate interior angles. Look at the sketch here. We just cut out like this part. Okay, angle 5, that will be equal to angle 4. And the reason is alternate interior angles. So the angles measured are equal to each other. Okay, I always use the Z to represent it. Okay, let me explain it why we want to use the Z. Okay, if you have the Z, when this angle, let's say this is the angle 1, this is the angle 2. We're gonna say angle 1 will be equal to angle 2. The reason will be alternate interior angles. Okay, and this Z, you could flip it. I can flip it like this way. Okay, so these two angles, angle 3 will be equal to angle 4. One more time, reason is going to be alternate interior angle. And also, I could flip it like the N. So this angle, that will be equal to this angle, or this angle, that will be equal to this angle. Okay, so look at this example again. So this is just like we flip the Z, like here. Here, here, here. So angle 5 will be equal to angle 4. Okay, just like this example. And one more time, we call this as alternate interior angle. Okay, so from this picture, 4 equal to 5. Another one, that will be, I could draw the Z here. Okay, do you guys see that? Here. So angle 3, that will be equal to angle 6. Okay, angle 3 will be equal to angle 6. Anything else? Okay, the second one, alternate exterior angle. So it's the idea will be same thing like alternate interior. Interior is talking about the corner inside here. Exterior, that will be talking about the angle outside here. Okay, alternate exterior angle. The example will angle 1, that will be equal to angle 8. Angle 1 will be equal to angle 8. And then we do have an angle 2 equal to angle 7. Okay, alternate exterior angles. The third one, that will be interior angles on the same side of transversal. So look at this example. We do have a two parallel lines here, an angle 4 and angle 6. Angle measures add to 180 degree. So we're gonna using the U to represent it. Angle 4 plus angle 6, that's equal to 180. Okay, this one will be using the letter U. Okay, and we say these two lines are parallels. And then the interior angle on the same side of the transversal, when they add it up, that will be equal to 180. Angle 1 plus angle 2 equal to 180 degree. Okay, or you could flip the U here. So these two angles, 3 and 4, angle 3 plus angle 4, that will be equal to 180 degree. Okay, or upside down the U, these two lines are parallel, and these two angles added up, that will be equal to 180 degree. Okay, so back to this example, we do have the U here. These two lines are parallel. Okay, so angle 4 plus angle 6, that will be equal to 180. And that's another one, the U is gonna be here. Okay, so angle 3 plus angle 5 is also equal to 180. Okay, the last one, corresponding angles. We'll be using the letter F to represent it. Corresponding angle. So F, these two lines are parallel. And then the corner here, they do have an angle measures are equal. So angle 1 equal to angle 2. Or you could flip the F here. These two angles will be equal to each other. Or upside down, there's a 5 and 6. So angle 5 will be equal to angle 6. And also, I could flip the F like this way. So these two angle 7 will be equal to angle 8. Okay, the reason is gonna be corresponding angles. Okay, go back to this example. We do have the F here. Okay, this is the F upside down, and the angle 2 will be equal to angle 6. And also, on this way, angle 5 will be equal to angle 1. And here, the F here. Angle 4 will be equal to angle 8. And also the angle 3, that will be equal to angle 7. And the reason will be corresponding angles. Actually, I usually use corresponding angles, interior angle on the same side of transversal, and alternate interior angle. And also the vertical angles. Make sure when you state that the angles are equal to each other, you will state the reason as well. Okay, example 1, finding angle measure. Find the measure of the angles 1, 2, 3, and 4, given that lines M and N are parallel. So these two lines are parallel. And then we have a line Q intersect the parallel lines. This is called the transversal. Okay, so we need to find angle 1, 2, 3, and 4. So first, angle 1, that will be equal to angle 4. Because these two angles are alternate exterior angle. Okay, so they will be equal to each other. We have a 3x plus 2 equal to 5x minus 40. Now, we're going to combine the 9 terms. We're going to subtract 3x for both sides and then add 40 for both sides. So you're going to get 2x equal to 42. And then we're going to divide it by 2 for both sides. So you find out x equal to 21. Okay, now we're going to plug in back x equal to 21 into here to find out the angle 1 and angle 4. So plug in x equal to 21. So we find angle 1 will be equal to 65 degrees. Okay, now after we find angle 1 is equal to 65 degrees, we could double check. We're gonna substitute 21 into here to see if we can get the same angle measure as the angle 1. Okay, plug it in, x equal to 21 here. And then we find it out angle 4 is also equal to 65 degrees. So this is good. Okay, now we could find out the angle 2, right? Angle 1 and angle 2, they are lying on the straight line. So this is the straight angle. So means angle 1 plus angle 2, that will be equal to 180. Okay, so angle 2, that will be 180 minus the angle 1, 65 degrees. That will be equal to 115 degrees. Okay, right? Angle 2 and angle 3, you could use the same reason. This is the supplementary angles. Okay, when they added up, that will be equal to 180. Or you could do angle 1 and angle 3, they are vertical angles. So angle 1, it should be equal to angle 3. Okay, so angle 3 is also equal to 65 degrees. Okay, make sure you guys show your work and state the reason why they are equal to each other. Angle sum of a triangle. The sum of the measure of the angles of any triangle is 180 degrees. Okay, example 2. The measure of the two of the angles of triangles are 48 degrees and 61 degrees. Find the measure of the third angle x. Okay, we just have this one. Sum of the measure of the angles of any triangle is 180. Right? So what we're gonna do? We're gonna add it up x plus 48 plus 61. That's equal to 180. The reason will be sum of the angles is 180. Okay, combine the 9 terms. And then subtract 109 from 180. You should get x equal to 71 degrees. Okay, right? Straightforward. Types of triangle. Obtuse triangle. A triangle in which one angle is greater than 90 degrees. So look at this example, this picture. So you could tell only angle A here, angle CAB, this angle is greater than 90 degrees. So that's why we call this is obtuse triangle. Second one, acute triangle. A triangle in which all 3 angles are less than 90 degrees. So we could write it down, angle CAB. Okay, when we write it down, angle CAB, we're going to look at the middle angle here. This is talking about angle A here. Okay, angle CAB is less than 90. And also angle ABC. So talking about the angle B here, also less than 90 degrees. Last one, angle BCA. So talking about the angle C is also less than 90 degrees. So this is called acute triangle. Last one, oblique triangle. A triangle in which no angle is a right angle. Okay, obviously this is less than 90, less than 90. And this one, it doesn't look like equal to 90 degrees, right? I guess it's going to be greater than 90. Okay, so we're going to say angle ABC not equal to 90. Angle BCA not equal to 90. And also angle CAB. So the angle A is not equal to 90 degrees. Okay, that's no angle is a right triangle. Another 3 types of the triangle, isosceles triangle. 2 sides are congruent to each other. This is talking about the side AC that will be equal to the side BC. And then two angles, angle A and angle B, opposite to the congruent sides, are called the base angle and are congruent to each other. Congruent means exactly equal to each other. Okay, so angle A will be equal to angle B. Okay, or you could say angle CAB equal to angle CBA. Remember that we're gonna say we only look at in the middle one. Angle A will be equal to angle B. And we call this as isosceles triangle. Okay, two sides are equal, so two base angles are equal. Another one, equilateral. All three sides are congruent to each other. That means AC equal to side BC equal to the side AB. Okay, you're gonna see the mark here, means these three sides are equal to each other. Since three sides are equal to each other, so all three angles are congruent to each other. So angle A equal to angle B equal to angle C. Okay, angle A equal to angle B equal to angle C. This is called equilateral triangles. Okay, scalene triangle. No two sides are congruent to each other. So you could see for this triangle, AC is not equal to BC, not equal to AB. So they do have a one check mark here, two check mark, and three check mark. Means they are not equal to each other. And likewise, no two angles are congruent to each other. So angle ABC not equal to angle BCA and not equal to angle CAB. Okay, these three angles are totally different. And we call this as a scalene triangle. Condition for similar triangles. For triangle ABC to be similar to the triangle PQR, ABC similar to triangle PQR, the following condition must hold. Corresponding angles must have the same measure. This is talking about angle ABC will be equal to the angle PQR. Okay, so angle B, that will be equal to angle Q. And also BCA, that is equal to the angle QRP. So angle C will be equal to angle R. Last one. Angle CAB, that will be equal to the angle RPQ. So angle A, that will be equal to angle P. Okay, so this is saying corresponding angles must have the same measure. And corresponding sides must be proportional. That is, the ratio of the corresponding sides must be equal. So we're gonna state AB over PQ, that's equal to BC over QR. And that's equal to CA over RP. Okay, you're gonna compare the same line in here. Okay, and you would find the proportional here. If it satisfies these two requirements, then we're gonna say triangle ABC is a similar. This is a notation of the similar. Triangle ABC is similar to the triangle PQR. Okay, one more time. First, check all of the corresponding angles. They do have the same measure. And then corresponding sides must be proportional. Okay, they should equal to the same numbers in here. If it satisfies these two requirements, then these two triangles are similar triangles. Look at this example. Finding angle measure in similar triangle. In the figure, triangles ABC and triangle NMP are similar. Find the measure of the angles B and C. So they are given these two triangles are similar and they want you guys find the angles B and angle C. So you're gonna compare. Angle A will be equal to angle N, which is gonna be 45 degrees. Okay, we're gonna say since the triangles are similar, corresponding angles have the same measure. Angle C will corresponding to angle P. Okay, if angle C equal to angle P, that means this angle is gonna be equal to 104 degrees. Last one, angle B correspond to the angle M. So angle B, that will be equal to 31 degrees. Okay, example 4. Finding side length in the similar triangles. Given that triangle ABC and the triangle DEF are similar, find the length of the unknown sides of the triangle. Okay, so similar triangles have corresponding sides in proportion. Okay, so we could say the DF corresponds to AB and DE correspond to AC. So we could write it down. DE over AC equal to the DF over AB. Okay, so we try to plug in the numbers here. And then now we will be using the cross multiplication. Okay, so 16 times the DF equal to 8 times 24. And then we're going to divide it by 16 for both sides. Okay, you could use your calculator or you could just simplify it. Divided by 8 here, divided by 8 here, you're going to get the 2. 24 divided by 2, which is going to be equal to 12. Okay, DF will be equal to 12. So we find it out this is equal to 12. Now we want to find the EF. So EF corresponds to the CB. So we're going to have the same ratio here. We're going to use the DE over AC and then EF over CB. Plug in the numbers and then use cross multiplication. Divided by the 16 for both sides. You're going to get EF equal to 16. Okay, last example. Workers must measure the height of the building flagpole. They find that at the instant when the shadow of the station is 80 meters long, the shadow of the flagpole is 27 meters long. The building is 10 meters high. Find the height of the flagpole here. Since this is talking about the shadow here, so these two triangles will be the similar. And then now we could calculate the corresponding side. Okay, we want to find the height of the flagpole here. Okay, so we're gonna use this line MN, that will be over 10. And then 27 over 18. Okay, MN corresponding to 10 here. And 27 is corresponding to 18. And then now we could simplify it first. And then use cross multiplication. Okay, you're gonna get this guy. And then divide it by 2 for both sides. So 2 divided by 2, that would be 5. 5 times 3, which is gonna be 15. So we know the flagpole is gonna be 15 meters high. Okay, this is a similar triangles. That's it for session 1.2.